I am Dipti Vyas from Statistics Department, MB Patel Science College, Anand. Now, before that, let us know. So, in earlier session, we have talked for the introduction of the non-parametric statistic. Now, today, the same session we will continue. So, today is non-parametric part 2. Now in earlier section we have talked about advantage, disadvantage, definition, also etc. etc. Now we will start with a test related with a non-parametric test. Earlier we have seen the one sample test, one sample sign test. Now let us start with a further test. Now today next test is run test. Related to run. Now what is a run? Run is nothing but the sequence of a letter. Sequence of a letter, as for example, suppose I will say run means, suppose a sequence is there A, B, A, B, L, I, so on. Then immediately after the completion of first letter or first similar pattern of letters means A, so one run is completed and then start B and so on. So this is tell us this sequence is nothing but a run. So test related with run is Wall-Wuffness run test. So in earlier session, due to the completion of a time, I have to conclude, I have to go fast. So we will revise it, this test. So here also let x1, x2 up to xn be an n observation having the density function, and similarly there is x, y1, y2, yn1 and 2 be a second independent sample with a probability density function f2 dot. For first is f1 dot. Then let us combine these samples, both the samples in a one sequence. So let us order them x1, y1, x2, y2 or y2, y3, then x3 and so on. So here we have ordered the sequence. So same the principle of ordered statistic has been applied here, and hence now we applied the test. So what is the distribution procedure? So distribution procedure, we have combined this PET sequence, and now here we have applied the test. So here as soon as the first observation x1, x2 and x3 completes, the one run is considered to be completed. Then y1, y2 is second run and so on. So if we want to see the distribution procedure, let us proceed with a slide. So here I have defined the run and then procedure start. So distribution procedure is let us combine two sample and arrange the sample in the order of the magnitude to give a combined order sample. And see, this is x1, x2, y1, y2, y3, etc. etc. So what will be our null hypothesis? So null hypothesis will be f1 dot is equal to f2 dot, which is equal to f dot, and which we can say that both the sample have the same probability distribution density function. Now here let us transfer x and y variable to u and v variable. So here we are standardized, here we are normalized it. Okay, so here hence the distribution of u and v under HO is given by probability of u is equal to 2k, and which is equal to n1 minus 1 c k minus 1 into n2 minus 1 c k minus 1 whole divided by n1 plus n2 divided by k minus 1. So here it is nothing but the negative binomial distribution. Now that probability was defined for the even sample, and if it is odd, then probability of u equal to 2k plus 1 is equal to n1 minus 1 ck into n2 minus 1 ck minus 1 plus n1 minus 1 ck minus 1 into n2 minus 1 ck and whole divided by n1 plus n2 cn. Now here the probability of type error is fixed and say alpha, which is the level of the significance, and u0, let us say u0 is determined from the equation, which is summation u is equal to x to u0 h of u, and which is equal to alpha. So for large value of n1 and n2 under HO, U can be considered to be the asymptotically normal, and the expectation of U is given like this, that 2 into n1 plus n2 divided by n1 plus n2 and plus 1, and variance of U is equal to 2n1 into 2n1 in n2 plus n1 minus n2 whole divided by n1 plus n2 square divided by into n1 plus n2 minus 1, and which is nothing but our normal statistic, or we apply the normal test, and therefore z is equal to u minus expectation of u whole divided by variance of u, and this follows normal with 0 1. So this is approximately for the large sample, and if n1 is n1 and n2 is greater than 10, then only this is better to apply, because for normal distribution, when we want to apply normal test, it is better to that the sample should be large. Okay, then here since our alternative hypothesis 2 is with too few runs, so the test is ordinary, one test, one tail only with negative value and leading to the rejections. So here let us take the example. So I have written the example. 25 individuals were samples as well as to whether they like or do not like the product indicated by y and n respectively. The resulting sample is shown by the following sequence y, n, 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 and etc., which you are seeing on the screen, and we have to test at the phi level of significance, and we have to test whether the response are random. So here y, n, 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 n. So first y, after completion of y, first run is completed and the next runs start n, 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 and so on. So here the numbers of the v is equal to 10, n1 is the number of y's, and which is 11, n2 the numbers of n, and which is 14. So setting up the hypothesis, so null hypothesis is the response are random. So here we have to test the response are random, level of significance is 5%, here so alpha is 0.05, and so let us apply test statistic. So under HO, the test statistic is, so I have calculated expected u and variance of u and apply the z formula, and hence I am getting z is equal to minus of 1.348. So critical values of tabulated value for z is, you are knowing that the for 5% the level it is nothing but 1.96. So what is the decision? The decision is the calculated value is less than tabulated value, and which is 1.348 is less than 1.96. So we accept the null hypothesis, and hence the response are random. Now next comes the test of randomness. So here one sample run test, after completing one sample run test, so first test was Wolf-Wnight run test. Now here the for second test is generally same procedure, here we are applying that run test only, but here the test for randomness. So how here its difference from the first test, in Wolf-Wnight test only run was taken into consideration, but here we are comparing this test with the test of median. So here what is the test for randomness? So let us see. So let x1, x2 up to xn be the set of n observation arranged in the order in which they occur. Xi is the ith observation in the outcome of an experiment. Then for each observation we see if it is above or below the value of the median of the observation. So here what we will do? So here we will assign the value A if the observation falls above the median, and B if the observation falls below the median value. And thus we get the sequence of A and B as the type of A, B, B, A, so on. So here after completion of first symbol A, so first run is completed, and then comes the next symbol, next run is completed, and so on. Now under HO, same procedure, that here also we can apply the normal test. So for large value of n greater than equal to 25 or etc., we will consider to be the normal. So here also we will calculate. So under HO the set of the observation is the normal, and the number of runs U is an random variable with the expectation of U is equal to n plus 2 divided by 2, and variance of U is equal to n upon n plus 2 divided by 4 upon n minus 1, and we can apply the normal test. Now for applying the test of randomness, so let us follow the trace procedure. So here comes the median test for two independent samples. So median test is a statistical procedure for testing if two independent ordered samples differ in their central tendency. So here since median is taken into consideration, therefore the measures of central tendency comes. So in other words, it gives the information if two independent samples are likely to have been drawn from the population with the same median. So what's the distribution procedure again? Suppose x1, x2 up to xn1 is an ordered observation samples from a population with density function f1 dot, and let y1, y2 up to yn2 be an independent ordered samples from the another population with density function f2 dot. So let us combine the two samples and arrange the observation in the order of the magnitude to give the combined ordered samples as, say, z1, z2 up to zn1 plus n2. So here we have given the order to the first sample and the second sample according to the, and we have here also applied the principle of ordered statistic. So here we have ordered the observation and ordered it, and hence we get z1, z2 up to zn1 plus n2. So here now how to define? So let m1 be the number of x and m2 be the number of y exceeding the median value of m of combined sample. So here I have defined m1 as the value greater than median and m2 as the value less than median. So saying, so what will be the test statistic or null hypothesis? So here f1 dot is equal to f2 dot. The samples come from the same population or from different population and having the same median. Then the joint PDF of m1 and m2 is the hypergeometric distribution with the probability density function. So P of m1 m2 is equal to m1c n1 into n2c n2 and whole divided by n1 plus n2 c m1 plus n2. So here m1 is considered to be less than n1 by 2 and hence type again level of significance error, and the equation and whatever equation is given by m1 less than m1 dash, where m1 dash is computed from the given equation above. So here summation all think probability of m1 comma m2 is equal to alpha, and the distribution procedure of m1 under HO is the hypergeometric. So here for applying the median test, here we the probability we are calculated from the hypergeometric distribution. So when you would be knowing, when we were considering where when we have applied the sign test, there we have there the probability of success and failure was equal. So at that time we have applied binomial distribution. So here also here we are applying hypergeometric distribution, and you are knowing the mean of the hypergeometric distribution is nothing but n1 by 2 if n is equal to n1 plus n2, and which is even, and which is equal to n1 of divided by n divided by 2, so into capital N minus 1 upon capital N if n is odd. So capital N is nothing but the sum of n